So, what happens if you're starting with a fraction whose numerator has a higher degree or a degree equal to that of the denominator? Well, you have to use long division before you can do the partial fraction decomposition. So let's talk about it. It says the techniques presented in cases 1 through 4 apply only to rational expressions p of x over q of x, in which the degree of p of x is less than the degree of q of x. If the degree of p of x is greater than or equal to the degree of q of x, we must first use long division to divide q of x into p of x. This will result in an equation of the form p of x, which is over q of x, which is the original fraction. It is going to equal some function s of x that is not a fraction plus r of x over the original denominator q of x, where the degree of this new r of x is less than the degree of q of x. Partial fraction decomposition can then be performed on the r of x over q of x. Okay, so in a nutshell, what's going on here? If you start out with a single fraction and the degree of the numerator is less than the degree of the denominator, you have to refer to cases 1 through 4. It's one of those 4 cases. If instead the degree of the numerator is equal to the degree of the denominator, or the degree of the numerator is greater than the degree of the denominator, you have to first do long division. Okay, and then you'll be able to rewrite your original fraction this way. Okay, so it's going to be something that's not a fraction plus this new fraction, and then you're going to be able to do the partial fraction decomposition on this new fraction. Okay, so that's how this is going to work. Okay, so let's try it out in example 5. Find the partial fraction decomposition for the given rational expression. 6x to the 5th plus 7x to the 4th minus x squared plus 2x all over 3x squared plus 2x minus 1. Okay, first thing we always check, degree of the top, and compare it to the degree of the denominator. The degree of the numerator, the highest power of x, is 5, and in the bottom we have degree 2. The highest power of x is 2. So this is a case where the degree of the denominator the degree of the numerator is bigger than the degree of the denominator. So we can't set up the partial fraction decomposition just yet. We have to start by doing long division. Okay, so I'm going to refresh your memory on how to do this. We're taking this top term, okay, and dividing the bottom term into it. Okay, one thing about long division, when you set it up, you have to make sure you have all the powers covered. So when you look at this guy, I have a 5th power, a 4th power, but I'm missing x cubed, so you're going to have to account for that. Okay, so I'm going to write down the numerator. This is going to be 6x to the 5th plus 7x to the 4th minus, well, I'm not going to put the minus x squared yet because I can't jump from the 4th power to the 2nd power. I have to account for the 3rd power. So I'm going to put plus 0x cubed. Okay, have to put a 0 in front because the x cubed is not really there, but this is serving as the placeholder. Then minus x squared plus 2x. Okay, and then if you want, you can go ahead and put 0 for the constant. Okay, all the powers have to be accounted for. Okay, we are dividing into this the denominator, 3x squared plus 2x minus 1. Same thing. If you had something missing, you might want to put a placeholder. Okay, all right, so this is how you do the division. Okay, you are going to start by comparing the first pieces. Okay, so the 3x squared to the 6x to the 5th. What do I need to multiply 3x squared by to get 6x to the 5th? Okay, well, you're going to have to multiply it by 2x cubed. Okay, if I do 3x squared times 2x cubed, 3 times 2 is going to give me the 6, and then x squared times x cubed. You add the exponents. It's a power of x times a power of x. You would add the exponents to get x to the 5th. Okay, so that's what's going on there. Okay, so you need to multiply 3x squared by 2x cubed to get the quantity 6x to the 5th. Okay, so then what you're going to do is take this 2x cubed and multiply it through this stuff. Okay, so I'm going to get 2x cubed times 3x squared. That's going to be 6x to the 5th. And then 2x cubed times 2x is going to be plus 4x to the 4th, because you're adding exponents. And then you're going to multiply 2x cubed by negative 1. That's going to be negative 2x cubed. Okay. And just think about regular division. If I went out to the side here and I'm doing 13 divided by 4, 4 would go into 13 3 times. 4 times 3 is 12. You have to subtract that out. So we haven't subtracted out yet. All I did was take the 2x cubed and multiply it through the 3x squared plus 2x minus 1. Now I'm going to subtract out my result. So that means I'm going to change the sign of everything. Okay, so the 6x to the 5th is going to be negative now. The 4x to the 4th is going to be negative now. And the negative 2x cubed is going to turn positive. Okay, that's what happens when I subtract it out. Okay, so then we end up seeing that the 6x to the 5th, those guys cancel because there's a positive one and then a negative one. And then 7x to the 4th minus 4x to the 4th is going to give me 3x to the 4th. And then 0x cubed plus 2x cubed is going to give me plus 2x cubed. And I can go ahead and bring down the next term. Okay, this is following long division of just numbers. Okay, it definitely is harder with the x's, but it is the same thing. All right, so now you compare again. What do I need to multiply 3x squared by to get 3x to the 4th? Okay, and the answer is going to be positive x squared. Okay, and actually, I made a little boo-boo here. Let me back this up. Okay, technically, I'm supposed to write things over the same powers. Okay, so that first thing I had was 2x cubed. Okay, I should have written it in over the x cubed column to be perfectly correct. Okay. Anyway, so again, what do I have to multiply 3x squared by to get 3x to the 4th? Well, the constants are fine. Okay. It's the x pieces to go from x squared to x to the 4th. I need to multiply by positive x squared. Okay. Because again, 3x squared times x squared is going to give me 3 times x to the 4th. You just add the exponents. Okay. All right, so we're going to do the same thing. Okay, we have to take the x squared and multiply it through 3x squared plus 2x minus 1. Okay, so if we do that, we're going to get x squared times 3x squared, that's going to be 3x to the 4th. Then x squared times 2x, that's going to be plus 2x cubed. And then x squared times negative 1 is going to be negative x squared. Okay. But then we have to subtract this result out. Okay, if you're subtracting something, that's equivalent to changing all the signs. So the 3x to the 4th is positive, it will turn negative. The 2x cubed is positive, it will turn negative. The x squared is negative, it will turn positive. Okay, so what happens? Okay, well, we have 3x to the 4th minus 3x to the 4th. Those guys cancel. We have 2x cubed minus 2x cubed. Those guys cancel. We have negative x squared plus x squared. These guys cancel. Okay, so then we're supposed to bring the next term down. Okay, and we have to stop because the 3x squared, this thing has a higher degree than this guy. Okay, so we can't divide this 3x squared plus 2x minus 1 into 2x. Okay, if we brought down the number as well, that's just a plus 0. Okay, so really the only thing that's left is 2x. Okay, so the long division is complete. We can't go any further, again, because the degree here is smaller than the degree here. So we have to stop. So think back to plain numbers. Okay, if I go back up to this 13 divided by 4, okay, 4 goes into 13 3 whole times. 4 times 3 is 12. You subtract it out, you get 1. Okay, what this tells us, and this is going to be helpful here, 13 divided by 4, that's what we just did. It is equal to 13, or 4 goes into 13 3 whole times. That's this top number, the quotient, plus 1, the remainder, out of 4 times. Okay, that's what this statement is telling us. Okay, 13 over 4 is the same thing as 3 wholes plus 1/4. Okay, and you could go to the calculator and see this. 13/4 is the same thing as 3 plus 1/4. Okay, you get the same decimal expansion. So if you applied that logic here, okay, this is what we can say. Okay, I'm going to come down here. We can say that the guy underneath, the 6x to the 5th plus 7x to the 4th, all that jazz. Okay, so 6x to the 5th plus 7x to the 4th minus x squared plus 2x over 3x squared plus 2x minus 1. This is equal to the quotient, okay, my result, which is this guy, it's going in, this 3x squared plus 2x minus 1 is going into the 6x to the 5th plus 7x to the 4th minus x squared plus 2x. It's going into it 2x cubed plus x squared whole times. Okay, so we're going to write 2x cubed plus x squared. Okay, and now we have to write the remainder. So we're going to put, this is positive, so it's going to be plus 2x over this thing. Okay, so 3x squared plus 2x minus 1. Again, it is tricky because the x's are involved. But again, it's mirroring division of just numbers. Okay, make up an example like I did when I did 13/4. Okay, 13/4 is the same thing as 3 wholes plus 1 out of 4. Okay, so I did the same thing to come up with this statement. Okay, so if you mirror what's in the box up here where you're doing the P of x over Q of x is equal to S of x plus R of x over Q of x, okay, that you can see that now. Okay, this is going to be the P of x over Q of x is equal to the S of x plus the R of x over the Q of x. Notice that these denominators match, and they should. Okay, so what's going to happen here, because again, we're trying to come up with the partial fraction decomposition of this original fraction. Okay, we couldn't go straight into it because the degree of the top is bigger than the degree of the bottom. But now that we've rewritten it this way, we can do the partial fraction decomposition on this 2x over 3x squared plus 2x minus 1, because the degree of the top is 1 and the degree of the bottom is 2. Okay, so I'm going to work on that and then we'll be able to write the final answer. Okay, so I'm out of room here, so I'm going to jump to a new page here. Okay, so we're going to work on 2x over 3x squared plus 2x minus 1. Let me make sure I wrote that down correctly. Yes, okay. So, by the way, this, you can't do anything with it. It's not a fraction, so it doesn't make sense to break it down into other fractions, okay? All right, so concentrating on this 2x over 3x squared plus 2x minus 1. Okay, so I'm going to jump over here. We're going to try to do the partial fraction decomposition of this term, okay? So the first thing I want to do is try to factor the bottom, okay? It may not factor. I don't know if this thing is irreducible or not, but I'm going to try to factor it, okay? So let's see what happens. I'm just going to try. This is 3x. 3x squared will break down into 3x and x. And then we need these other numbers to multiply to be -1, but we need the middle term to work out to be +1. Okay, so I've done this forever. I think it's going to be this. Okay, let's check. Okay, so if we multiply this out, this is going to be 3x squared plus 3x minus x minus 1. Okay, and if you combine the like terms here, you are going to get the bottom, 3x squared plus 2x minus 1. Okay, so this is how we start. Okay, the denominator does reduce here. You can break it up, you can factor it further. Okay, so this is how we're going to start. Okay, so looking at this, okay, what kind of factors do I have in the denominator? Okay, each one of these guys, they're different, they're distinct. Okay, the highest power in each one is 1. So these are linear distinct factors. Okay, so that's what we have here, and I'll write that down. These factors are linear and distinct. Okay, so this is really going to be case number 1. Okay, so we know what to do. Okay, so in my next step, okay, I'm going to take the 2x over 3x minus 1 times x plus 1. Okay, and I'm going to have to break this up into separate fractions. Okay, neither of these guys is repeated, so each factor will produce one new fraction. Okay, let's start with the 3x minus 1 term. Okay, we're going to have a fraction over 3x minus 1. Okay, this denominator is linear, it's degree 1, so that means the numerator is going to be degree 0. It's just going to be a number. Okay, then we're going to add some other fraction. We are done with the 3x minus 1 because that factor does not repeat. Okay, the other factor is x plus 1. It does not repeat, and so we'll just have one fraction over this factor. Okay, it too is degree 1, so that means in the numerator here we need to have degree 0, just a number. Okay, so that's how we set this up. Okay, and so now we need to get rid of the fractions. Okay, so I'm going to rewrite everything and leave myself some room to clear the fractions. Okay, so let me write this out. All right, so here we go. Okay, if we want to get rid of the fractions here, we're going to start on the left side of the equal sign where we have the full denominator. I'm going to multiply by the full denominator. That way it's appearing in the top and the bottom and they will cancel. Okay, if I multiply the left side of the equation by 3x minus 1 times x plus 1, I have to do it to the right side of the equation, meaning I have to do it to all the parts. Okay, so this a piece, I'm going to multiply by this quantity. The b piece, I'm going to do the same thing. Okay, so now we can clean things up. Okay, on the left side of the equation, I see 3x minus 1 in the top and the bottom. They cancel. X plus 1 in the top and the bottom. So I am going to be left with 2x. Okay, if I move on to the a term, I see 3x minus 1 in the bottom and in the top. So I am left with a times the entire quantity x plus 1. I've got this plus sign that I need to bring down. And then on the b part, I see an x plus 1 in the bottom, 1 in the top. I am left with b times the entire quantity 3x minus 1. Okay, the fractions are gone. Okay, our gut tells us to go ahead and distribute. So we're going to get 2x is equal to a times x plus a plus 3 times b times x minus b. Okay, we need to combine like terms on the right. Okay, so I'm just going to rearrange this. On the right side, I have an ax and a 3bx, so I'm going to put them side by side. And then I have an a, which is just a number, and b, which is just a number. Those guys don't have x's, so that's going to be my constant here. So we're going to have plus a minus b. Okay, And now we're going to group things. Okay, on the right, I have ax plus 3bx. Both of those guys have an x, so you can factor out the x, and I'll do so on the right. You can also look at it as you have a many x's and then 3b many x's, so you have a total of a plus 3b many x's. And then the constant is just going to be a minus b. Okay, you can group that. If you distribute the positive 1, it's just going to give you a minus b. Okay, at this point, we need to equate things. Okay, so the numbers on both sides of the equation, the numbers in front of the x piece have to be the same. The constants just have to be the same. Okay, remember, 2x is the same thing as 2x plus 0. Okay, so the number in front of the x on both sides of the equation have to be true. This is going to tell us that a plus 3b has to equal 2. Okay, remember, you don't bring the x's with. Okay, you're just comparing the numbers in front of each power of x. Okay, and then the constant pieces have to be equal, so a minus b needs to equal 0. Okay, so a minus b has to equal 0. Okay, this leaves us with a system of 2 equations and 2 unknowns. We solve through elimination or substitution. Okay, this one looks pretty straightforward. From the fact that a minus b is 0, this is going to tell us that if we move the b over, a and b are going to have the same value. A has to equal b here. Okay, now that we know this fact, we can plug it into the first equation. A plus 3b is equal to 2. We know a is the same thing as b, so we can write b plus 3b is equal to 2. This is going to tell us that 4b is equal to 2. Divide by 4. We get that b is 2/4, which is 1/2. Okay, so we've got b is 1/2. Okay, but a is the same thing as b, so a is also 1/2. Okay, so here are our coefficients, okay, for the partial fraction decomposition. Okay, all right, so now I'm going to write all of this out. Okay, so I am going to go up here. Okay, I just learned that the a value is 1/2. I know the b value is 1/2. Okay, now remember, this was only part of the original fraction. Okay, so let's go back and write out this final answer. Okay, make sure you don't miss any of the parts here. So let me go to this other page. Let me go below my work here and start writing this out. Okay, the original fraction that we were looking at is 6x to the 5th plus 7x to the 4th minus x cubed plus 2x all over 3x squared plus 2x minus 1. This is what we were trying to decompose. Okay, after the long division, we learned that this fraction is 2x cubed plus x squared. So 2x cubed plus x squared, you cannot forget that, plus this other fraction, okay, this 2x over 3x squared plus 2x minus 1. This is what we did the partial fraction decomposition on. So when we tack on the 2x over 3x squared plus 2x minus 1, we have to give the partial fraction decomposition, which is up here, okay, and we know the a and the b values. Okay, so at this point, we are going to apply this thing that I'm highlighting in yellow here, this guy. Okay, so that's the last piece we need to add on. Okay, so this is going to be, if I rewrite this, okay, this, I'm going to go out to the side because I'm running out of room here. This is going to be 1/2 over 3x minus 1 plus 1/2 over x plus 1. This is a complex fraction. You have a fraction within a fraction. Notice that for both of these pieces, okay, if I have the 1/2 here, I can keep the 1 in the top and send the 2 to the bottom. it's the same thing as this algebraically. Okay. Reason being, okay, if you did this as 1/2 over 3x minus 1 over 1, you would have to leave the 1/2 alone, flip the bottom fraction, okay, and then multiply across the top and across the bottom. So this 1/2 over 3x minus 1 is going to be the same thing as 1 over 2 times the entire quantity 3x minus 1. Okay, and for a similar reason, when you add the 1/2 over x plus 1, this is going to be 1/2, or sorry, it's going to be 1 in the top, 2 in the bottom for the 1/2, but you're going to be multiplying the 2 by the quantity x plus 1, okay, just from dividing the fractions out, okay? So this is what we need to add on for the partial fraction decomposition, okay? So we're going to come down here, we're going to put plus 1 over 2 times 3x minus 1 plus 1 over 2 times x plus 1. And this is going to be the final answer right here. Okay, I'll put it right here. This is the answer. Okay, so you need to remember, if you encounter the initial fraction where the degree of the numerator is greater than or equal to the degree of the denominator, you first have to do long division. And you will have to do the partial fraction decomposition on the new fraction part that comes about. Okay, so make sure you review this type of example.